Can you hear that? Time is running out because the lifespan of our planet is leaving us. It's running out. It will not last. 2 days ago, the emission gap report showed us that CO2 emissions keep rising. And they're threatening that even if we keep ourselves to unconditional commitments that we have made in the Paris Agreement, we will not make it. This will be my last threat today, but I want you to feel it the way I feel it. So thank you very much to the organizers of this meeting to invite me here. And dear participants, you have been already in this meeting for a number of days. So I'll try to not exceed my time and make it interesting for you. I'll be talking about climate change, about pathogens, about infectious diseases, and what it means, but also shed some light on what we can do about it. So hopefully we end on a more cheerful note than I just started. So the World Economic Forum in Davos actually came up with their risk landscape. That's what they do every year. And this year, for the first time, the high likelihood and high impact of environmental risks was very evident. So there's some societal risks that we have to worry about, but most of the risks, the global risks that we anticipate, are actually coming from the environment. So there's extreme weather events, high impact, high likelihood. There's failure of climate change mitigation and adaptation, and natural disasters. So how these impacts actually relate to health, I will explain to you in the next slide. We'll see rising temperatures, we'll see extreme weather events. We have all other climatic events that relate to either air pollution, relate to an increase in allergens, relate to an increase in water and foodborne disease. And what I've seen this afternoon in the poster session is that's all very close to your heart. This was to introduce actually how climate affects health, but we should not forget one of the other, maybe less obvious factors, which are social factors. So I can't walk around, I think. I will do it anyway. So I hope this can be turned on. Does it work? Yes. So here on the far right-hand side, you can see physical and mental health effects of conflicts and disasters. And I think that we truly shouldn't forget about this. Then how that could work out is actually what's indicated here is that we may face a rising number, which is very probable, of asylum applications in the European Union because of climate change. And of course, we all know how impacts of climate change will affect health in developing countries much more than with us, because we have a very good public health infrastructure, and seeing all of you, my confidence rises. But in those countries, this is not the case. So what are we talking about when we talk about climate change? Because a lot of people talk about climate change all the time, but it's quite complicated what we're talking about. So you need to think about snow and ice melt, and therefore sea level rise, rainfall, an increased ambient temperature, flooding which may occur, but also relative humidity and evaporation, and a higher water temperature. So some effects are more direct, and some effects are more indirect. And I'll explain a little bit more what that means. So maybe it's nicer if I walk to the other side of the room and explain it here as well. So in terms of direct effects, actually, we always talk about rainfall. So this will be increased rainfall, but in some cases there may be more droughts. And it may actually be the case that we have more droughts, but at the same time, when it does start to rain, there will be extremely heavy rainfall and we can't cope. For instance, yesterday in the Netherlands, we faced I think this was the first time this autumn, heavy rainfall, and we had 1,000 kilometers of traffic jam. We just couldn't handle it, but let alone that, there's solar radiation and ambient temperature, and then more indirect effects. There's also effects on carbon cycle. So it means that our soil will act differently in the nitrate cycles. The currents will change, the sea level may rise, and there will be changes in relative humidity. What we need to realize is that at this moment, people are already implementing measures of intervention to make sure that we're adapted to climate change. And not only that, but also many measures to mitigate the CO2. What that means is that actually we have to proactively think and talk about human health impacts, because what happens is it will be very complicated, and I've been trying to do this for the past number of years. It's very complicated to tell people who are much involved in CO2 emissions and CO2 emission reduction to think about other effects, that maybe their intervention measures may be all very well meant, but they didn't think about good options for health. So this is something to take into account as well. And now you will understand about climate change, and mitigation and adaptation. You can see in this slide actually what one of the most direct effects means. So there was a study, and you can also see Northern Europe here, and Central Europe and South Europe. But overall, what we have seen is that actually the decrease because of warmer winters is not outweighed, or actually is outweighed by the higher disease incidences or deaths, excess mortality, because of heat in summer, because of warmer summers. This is one aspect that is very important and is a direct effect, but there's also many, many indirect effects. An example of indirect effects may be water scarcity and flooding, and there's many factors outlined here, but what I'll do is I'll give you some case studies where that's exemplified. So what we see is that if you look into waterborne infectious disease as an example, and climate change, that actually the two major global climate change effects that give the highest number of illness and most deaths are extreme weather events and flooding. When you then look at the predominant waterborne pathogens, of course this is from published literature, keep in mind you cannot always, everywhere, do the diagnosis properly. So what you'll see here is Vibrio and Leptospira as the top pathogens that were detected. But of course, those are more easily distinguishable than the others without any diagnostics. Because you have to imagine, if there's flooding events, you don't have a laboratory. And also, you're not interested in the laboratory because there's people who are dying. So this is not on your mind. On the other hand, these are important pathogens and important infectious diseases when it comes to climate change. So as an example, Vibrio species, we've learned in the last number of years a very interesting study by Rita Colwell and colleagues, was that what they saw was there was a higher level of Vibrio bacteria associated with a higher water temperature. And in coincidence with that, we also saw a higher number of Vibrio cases. One specific example, a hot summer in 2006, cases were noticed all around Europe, specifically also in northern countries where they were usually not observed. This very warm summer, what we could do was look at data on concentrations of Vibrio species. This is, of course, not talking about Vibrio cholera, you all know. This is Parahemolyticus, Phoenicus, those kinds of Alkynolyticus, those Vibrio species. And what we saw when we did climate projections based on IPCC scenarios, and the Dutch version of that, was that actually we could project that there were 2 to 3 times more infections in up to 1 in 10 to 100 risk of illness. And then this is my daily reality per person per summer, which is maybe not something you usually see. So that's with respect to a higher water temperature, what that can mean. And then there's another example, emerging infections, already mentioned it, like leptospirosis in Europe. So this has been re-emerging, and in terms of sources, of course, these are related to rodents. And what we have seen is actually with the expansion of the rat population, we saw an increased number of cases. Although on the other hand, it does vary. It's not steady increase, but there's variation, and we have to look into the climate data much more. That's what we did in the Netherlands, or colleagues of mine did in another part of the institute. They looked at leptospirosis, and they noticed if there's warmer summers, there's an increased incidence. So that's a different type of relation of climate change to infectious diseases. If you continue with enteric pathogens, it can be quite different. What you see here is a consequence of pluvio floods. So what happened was actually, what you see here is a quite harmless one, which is an additional reservoir or pool where temporarily water can be stored. But on the other hand, overflowing sewers. I don't know if you ever have those on your 8 o'clock news, but we do. There's children happily floating about in these sewage impacted waters, which always is a bit difficult for me to look at, being a mum. So that's a different case altogether. And what we did was, we did research. I don't want you to memorize this is all published. But what we did, we combined concentrations of waterborne pathogens that we actually measured in the water in different types of urban floodwaters, combined it with questionnaires that we did in adults, and also asked the adults about children and their exposure. And by combining these data, what we could actually do is using a quantitative risk assessment, which is one of our expertise, I could say. And what we found was if the exposure to floodwater with a higher level of contamination is the case, then you find higher levels of risk of infection. I find it a bit difficult to point it out. I'm normally used to pointing things out, but hopefully you can understand. So the higher level is the higher risk of infection. And what we did was we actually calculated in a different way as well to make it more understandable also for policymakers and professionals. So what you see here is the frequency of flooding per year. And actually what you can see is even with a low number of flooding events, so water on the streets, you can see that already the increase in risk of infection is quite noticeable. So with that, I'll move on to Legionella, which is also very close to my heart. I think all of these topics are close to my heart, including microplastics and animal husbandry and all these other interesting topics. But Legionella, actually what we saw was, what is seen across Europe actually, is that there's a steady increase in endemic Legionnaires disease cases. So previously, Legionellosis was much related to visiting hotels in certain parts of Europe. But you can see very clearly here, when you look at the blue bars, that the infections that people acquired in abroad is actually quite steady, but the endemic cases are on the increase. And I was in Belgrade last week, where we saw the latest figures on Legionnaires at the Protocol on Water and Health meeting, and this is actually also the case where it's still not so much known as countries like Hungary and Czech Republic. And what I want to show you here is this was actually published by, or written up by an EPIET fellow that I work with. So I want to specifically mention him, Johannes, he's in the room. And what happened is the study showed how a heavy rainfall event succeeding hot weather will actually give an increase in number of cases. And what's interesting, in the past 2 years, what we have experienced is a summer where it was very dry, but there was heavy rainfall and subsequent increases or peaks in cases. But last summer, there was also a drought going on. And what we noticed was actually the numbers of Legionnaires' disease cases dropped below the 5-year average. So it's really these, not just the hot weather, not just the higher temperature, but it's also a higher relative humidity. So that's not all, because I don't want to keep you away from this. So previously we thought it was drinking water, but the majority of sources remains unknown with respect to Legionnaires' disease. And so what we did was actually, we noticed in a Dutch town how there were clusters of cases, and we checked all the risk factors, seemed quite normal. And what we also did was we used a spatial model for source identification together with colleagues in the EPI department. And what we found was that there was a biological wastewater treatment plant. So what we could do with this spatial model, which this is also published work, but in the red square, that's the most likely place where the source would be. And actually the biological wastewater treatment was very close to that. So it was a nice indication. And also we found the same sequence type in patients and in wastewater treatment plants, 1646, for those who are interested. So what we're actually doing now, what is ongoing, is that we're actually mapping out all the wastewater treatment plants, because a biological wastewater treatment plant is a bit different than a municipal wastewater treatment plant, but you have to have a bit of an environmental background for that, I guess. But we're looking into that and seeing whether there are cases that have occurred in the past couple of years, and whether they were also associated with causing Legionnaires' disease cases in the vicinity. And I must admit, it's over 6 kilometers, so it's much more further away than we anticipated previously. And we're also looking into relation to climate. With that, I'll want to go into tools and recommendations with you, because I don't have so much time. So one thing to take home is any pathogen is actually climate dependent. Has nothing to do with climate change. It's just, it has a relation to climate. So if you look at bacteria, viruses, and parasites in soil, water, and air, you'll find that they have a certain behavior, and some like it when it's dry, some like it when it's hot, some like it when it's cool. So this is something to keep in mind. They're not the same. And the other thing I want to point out is that these climate change are already ongoing. We have hot summers, cold summers, dry winters, any other combination. So we have to keep in mind that this is already going on right now. And what are these characteristics that we have to take care of or keep in mind? It's not just the size, the numbers, the morphology and chart. This one's for particular someone in the room, size matters. Infectivity, pathogenicity, but also when you look here, you can see resistance to temperature And actually, resistance to desiccation is quite different for different bacteria. And they have different mechanisms to actually resist droughts. So something that you really should take into account if you're doing research in the coming years. A bit of a complicated schedule, but just to show you, if you're going into a risk assessment framework for these direct and indirect effects, in this case for waterborne infectious disease, then there's so many factors to take into consideration. But I still think that this is a very useful framework, because there's assumptions you can do scenario modeling, and in the end, it really gives you at least, maybe not absolute risk of infection, but at least relative risk of infection. So if this is going on and the temperature rises by so much, or there is so much more rainfall or so much more drought, or the relative humidity behaves differently, then at least what it tells you is what you can expect in terms of change. And how we use that is we work together with ECDC. I must admit, it's already some time ago, but quite happily worked together with Jan Semenza and other colleagues. And what we actually produced was for member states to have a decision tool to see how to prioritize which infectious diseases to take into account. In this case, specifically foodborne and waterborne pathogens, but to be able to target the proper main pathogens in your regional circumstance, and also to take into account that funds are not limitless, so to really target funds to where it's most effective. This is a risk assessment tool. The advantage is you don't have to know a lot about modeling, but you have to know your own location. So if you can put in data on local weather circumstances, other local circumstances, you can use this without being a modeler. And I can say so because my background is in virology, actually. So if I can understand it, you can. This is another tool that we have in the Netherlands. We've developed it. It's called the Water Quality Check. And I heard someone mention about a splash park. There was an outbreak in a splash park. Very nice. Ah, I can see you there. That's you. Very interesting presentation. And we were talking about tools that you can use to actually assess risk. And what we've done is we looked at different urban water concepts and looked where hazards and hazardous events may occur, and then see if you can make sure that attention goes there and that the least bad option is chosen. We're also working nowadays with people who are actually architects in different cities, and they will choose the most beautiful option. And now we're trying to make sure that we choose the most beautiful option, but also the one that's safer when we compare, and also take into account climate and infectious diseases. So something which can be useful for looking into your environment. And I think I also mentioned this before, but actually climate will affect us in Europe. We saw the first cases of West Nile, for instance, occurring now in Germany, but my colleague Jet will go into that. And what we, for instance, have been doing is developing climate-resilient water safety plans. And I think these are actually also very useful anywhere in the world, because what you actually do is you look at a certain water source and then decide, is it gonna be still there when climate changes are progressing? And what you can make sure is that you still have enough water of good quality for all these different purposes, whether it's recreational purposes, drinking water, irrigation, all these different purposes that you need it for. And then I come to one of my last slides, and I think I'm doing okay on time. Other global challenges that we have to take into account are actually urbanization, but there's also microplastics. We already saw displacements also a problem, and aging and population growth. And I think in all these cases, as well as for climate change, we do need to take into account that there's also health and how we should have keep it in mind and make sure that people who are working on these topics also think about human health. With respect to monitoring and surveillance, there's a large research challenge, I think, because we need an integrated monitoring and evaluation system with the right indicators to identify health effects, but also evaluate measures. And this is something that we clearly need to do in future. And then we should not forget about all these other sustainable development goals other than number 13, because they're all related. And if we intervene somewhere on the side where it's all about economic growth, or it doesn't actually matter which one, but we should keep in mind that it doesn't mean that there's no effect on the others. And with that, I would like to express my special thanks to Professor Andy Haynes of the London School, who provided me with 2 slides. And I want to point out that this girl is very wise. She says, if politics or politicians don't want to listen to science, why should we go to school? Thank you.